it would be great if they get the DOI, and I think that is really an important step and possibility with this DOI mechanism.
Before Naim, I would like to double down. Yes, please use whatever we already have. Yeah? It's water under the bridge. There is no more any one of these questions, right? It's already public, except it doesn't have a DOI. So let's capture that, a snapshot, say these 10, 20, 30, whatever we feel comfortable, especially the authors of these reports to me are the ones that need to be asked how comfortable they are. They may want to do editorial or other changes. But yes, Sel, 100%. I saw Femi raising his hand, but I believe Naim is waiting.
Yes, okay. Thank you very much again, Charles, raising this important point. That's I would like to be reinforced as well, because first of all, for all the remaining or go beyond the VQuag, we should have two steps we have to be do. One is the quality control. Not very tight, but at least should be, as Yanis mentioned, that one should be relevant and should be authenticated by the community first, right, that we have, and then we can go beyond. And the second thing, if we have to go beyond the scope of the VQuag, then we have to be define some charter of it as well. It is not like that when we can blindly go and then go. So right now, as Yanis mentioned, and the also shall support that one, first we will utilize what we already have and then put it these things and then also give a trial until in the next meeting, then we can go a little bit more open on it. So I think so the best way of approach is that one, by the next week meeting, either it is on, definitely it is online, but we should have to start populating this DOI with the existing material, and then we will revisit all these things and then see that one, how can we can go beyond you can say that we quick boundaries, or either we don't need to be, and then how to be quality control will be materialized, and all these things we have to be somehow to be mechanized to be go beyond that one. That's my suggestion.
Thank you, Naim. I see Alex raising his hand.
Yeah, thank you. I fully agree with this. I think the tricky part will really be this quality control, so to speak, right? I mean, because, I mean, on the one hand side, I think it's very good if we really get as much as possible out, which we consider valid, right? But how do we get to what is valid, right? Or relevant, right? Because, and maybe some people are naturally a bit more concerned and let me say shy to actually suggest their works to be, you know, getting a DOI because maybe not mature and was just a presentation, versus others may want to possibly push for it or so, right? But at the same time, we also don't really want to be hindering it. We're not going to be introducing a real peer review, I'm thinking, right? So, and I think this is going to be something, this mechanism you mentioned, I think that's something where I really would be happy if that was the next step to work on, that we get in this very nice and contribution-driven and you know, volunteer-driven approach, a good mechanism to keep the quality up. Thank you.
Yeah, up for discussion, right? And that's what we are here for. I want us to somehow reflect archive in the sense that we should not really be doing archive doesn't do any peer review, right? It's a repository. And there are big disclaimers, right? We don't know if these guys own the content, right? You make a declaration that say, I'm the author. The same set of disclaimers will go to whatever. But I think I want us to be sort of a filter. If someone wants to look for work related to video quality, I really want us to become the go-to place. So if it was produced by the group, without a doubt, it should be there. There is actually, it shouldn't be anywhere else, in my opinion. If it was produced by a researcher that is part of the group, but they didn't do it within VQuag, I think it should be there, right? So if Pablo or Alex or anyone here, and the extended community have done the work, and they didn't do it as part of a formal VQuag, that to me is the second sort of tier, right? And then if a researcher that has never interacted with VQuag, but they are still in the general field, they have published elsewhere, and they say, hey, I saw you guys have a dedicated DOI, and then here's my work, right? At that point, I think we should have a set of rules. We shouldn't be obviously hosting content that's, let's say, either offensive or otherwise, improper. I'll use this general term, right? I don't want us to have any connection with that type of content. But any reputable researcher in the general field of video quality should feel that the VQuick DOI is a natural home to at least host their work. That's my suggestion, but again, this group will decide. Anything else related to DOI? Pablo.
Yeah. Just to clarify, is the proposal that we store both the metadata, of course, and the document itself, right? So if, let's say, I want to archive some QoE work under VQuick, it should be the document and the metadata itself.
I don't have a strong opinion, and I would like to take your and others' opinion of it, right? So I'll be very specific, and I'm not doing it because it is a little bit selfish, right? But again, the VMAF tech blog is hosted by Medium, right? Medium is a well-known platform where people, publish. It's okay for them to be the host, but the metadata and the DOI comes from VQuick, but it points to the Medium PDF, and that's okay, to me at least. Whether we decide to also host a copy of that, or maybe move it from Medium to the VQuick now hosting, that's a separate question. I would like to separate and keep it on the metadata layer for now. Because many people already have in their, say, university, they may have in the research group at the university an already version of a PDF, which may or may not have a DOI, right? I would like that to be included into the VQuick DOI without moving also the PDF to our website. That's my suggestion.
Yeah, so two smaller side suggestions. One is maybe we should continue this in the next meeting. Let's say I have kind of a proposal of a structure that we can fill, right? So, for these kind of options. And second, very specific, I volunteer to prepare the DOI metadata for the existing documents as soon as somebody helps me with the. So I'm also publicly asking, probably Cel and Naim, if you would be willing to help me in creating the metadata for the older publications, because I don't have the information for that.
Volunteers, we really need drivers here and owners. So.
Yeah, sure, Pablo. Yeah, we will coordinate with you.
Yeah, I'm happy to also be able to help.
Anything else on DOI?
I just have a question about the data set, not the paper, but the data set itself, like image or videos, like what you have in video set, for example, an IEEE port you uploaded. Are we going to have such repository also for the data set?
That's an excellent question that I was about to introduce in the follow-up, because back-to-back we are supposed to talk about the future of VQuick again. Part of my thoughts is that we as not just us, the community is moving from the research community is moving from producers of reports to producers of data. And machines elaborating the data and producing reports. But again, that's just my philosophical thinking here. But in a practical sense, and I know it's too early for Margaret, as you know, there is CDVL. CDVL to me is an amazing resource that is underutilized. Again, it's loosely or tightly, depending on your point of view, related to VQuick and our data sets. And there are additional data sets that either one of you or each one of us has produced, subjective, objective, stimuli, etc., that, in my opinion, we should double down. We can definitely obtain a DOI identifier for this as well, right? Because you don't need to point to a PDF, you can point to anything. And that could become maybe the most valuable resource that we leave to the world down the road. So if you want my opinion, I would say data sets should definitely be part of this discussion, not only outputs, documents, and we perhaps need to be part of our refocusing on what do we do as a group and where is our value. But I'm opening up for anybody else to chime in on the question about data sets.
Well, my question is, because it's not fully clear for me. I understand once you get DOI, it's the one number. So if I'm sharing something on Zenodo, for example, it's a platform for data sharing, the data will get the DOI there, and then I kind of cannot link it to the VQuag, unfortunately, anymore. This I would see like, because I see a big value of collection of things related to video that is in one place. On the other hand, you know, those systems are kind of easy to use because they are built for really hosting large amount of data, etc. So
let's not confuse hosting, right, with DOI. Just like where we have the 5G KPI report, the PDF is different from, because all that Crossref is doing is resolving, right? Tell me, I'm giving you this DOI, tell me the metadata. Part of the metadata is a link. Right?
Okay.
So the discussion we have right now is not whether we should move our collective data sets to a central repo. The question is, should we also offer the ability to create DOIs for data sets wherever they might be hosted, but at least going to be under the VQuag because it is thematically and substantially maybe the most relevant part of our work.
So I understand that this would be like hosting it on Zenodo, but not Zenodo is creating DOI, but I'm saying I already have DOI for that. This would be something like that. It's possible, yes?
DOI is like an indirect addressing. You go to DOI and you can have your contents in different computers in the same organization or in different countries. Because after you obtain the pointer, and the pointer can address any part in the world.
Okay, so another proposal from my side would be that if we write something that needs cite, something within the VQuag, if it's report or presentation, regardless, then I understand that this would be a good idea to try to start from if something that I want to cite does not yet have DOI, then I go through all the process to create it, yeah? So asking the authors and then creating it, etc.
Correct me if I'm wrong, Pablo, but nobody stops you from having two pointers pointing to the same object, right? As far as I know. Therefore, just for the value that one has a central location, to me is important. So I would say once you, but again, we're talking about the third order problem now, right? We have to solve the first order problem, which is the work, the e-letter that has been done, right? Assuming we solve that. Moving forward, what we do for our meetings, solve that. Then we're going to go ahead and maybe re-index potentially already DOI'd data sets or other objects, right? But I see no blocker. The vision, in my opinion, would be to have the home of all things related to video and visual quality is this, right? It comes from the VQuag prefix, and everything is below that.
Nice idea, thank you. I see we still have a question online.
I got my hand, but anyway, I can ask another question. That the DOI for the data set, I think it's possible even the different version of the same data set has a different DOI. So even it is common, I think. So it's fine. It should be.
All right. Anything else on DOI? And I'm happy that we have, again, I'm grateful to Pablo and everybody else because it took a little bit of a back and forth, right, how to find it. The Crossref itself had a waiting period of almost a month, but happy to be here. Okay, I think we only have 15 minutes before our lunch break. Is it 15?
Exactly.
Yeah. So I think it can be a short discussion. I should have prepared slides, but to be honest with you, the way things move these days, the slides that I would have prepared 2 weeks from now, maybe they're already superseded. I'd like to kick off this very short report of where we are on the administration about the future of VQuag and remind everyone that it was 3 meetings ago when a proposal was presented. And the key bullets here is, should it become a formal group from an ad hoc group? Number one question, right? And one of the proposals was to become a non-for-profit organization. The original idea was to be US-based, and I presented what's the legal framework and what were one of many ways to achieve that, right? So that's one broad topic, let's call it the legal status of VQuake. But to me, what emerges more and more, and I hope we can address it maybe through our projects, but maybe not. Maybe we need to have maybe the broader scope of our organization change, is what happens in our field and what the work that we are doing today, as it was presented earlier this morning about the nice list of projects, how relevant to the rest of the world is on May 18, 2026, because I have zero doubt about the relevance and the importance of our work from 1997 until a year ago. But I want to be very clear that the signs that I see in the industry where I'm involved, I don't want to be calling specific activities, but broader, is that we are in a transformational phase. And that transformation that touches everything that happens in the tech world, first and foremost in industry. Academia, because of the longer time constants, is one of the few cases where it's lagging, but I think it's inevitable that it will get there. How does it touch upon what we do or what we should be doing? Where is our value? Is really the number one question I have today, my top of mind. And the reason I'm bringing this up is because I'll bring two very specific examples, right? I think more than 50% of the people in this group, and including those who are remote, have either performed or plan to perform subjective experiments, right? Subjective is one of the key pillars that provided immense value to the world. But if you ask many tech companies, do you plan to do any subjective experiment? And what type of subjective experiment would you like to do, right? Will it be single stimulus, ACR? The answer is, why should I do a subjective experiment, right? So the very, very, very first question that I would pose to the group, what is the role of subjective experiments in the modern era where the much used and abused term AI, which means different things for everyone, but I think we all know what I'm talking about, is here today. So that's question number one, specifically on subjective experiments, right? But even if you go down the path of objective metrics and methodologies that we have built, the rate of papers that I'm reading on this topic from researchers that I have never heard of, that doesn't mean they're bad researchers, by the way, right? It's not like I know everybody who's doing research on video quality and objective metrics. Is to me surprising, because the tools have enabled people with much less background or even zero background in this topic to allow me to use a word, to cook a recipe that you feed it some data and a score comes out, right? So therefore, the next question would be, what is the value that we bring on this other front, which is objective metrics and all their usages, no reference, full reference, right? These to me are the two burning questions for the group to remain relevant. Of course, tied up to whether we're going to keep doing these meetings in person, remote, are going to have a legal presence, where, how. And I would like to hear first, I know it's only 10 minutes now. We're going to have both the breaks, which I want us to be brainstorming. I want to hear each and every one of you, if possible. What do you feel? Because that's my view. I shared with you my view. I see this imminent, I don't want to call it threat, right? Because threat is something you are afraid of. Because I'm not afraid of how AI can use and help our community. Threat is only viewed for someone who doesn't have the means to evolve. To me, it's a challenge, it's not a threat. The challenge for our group to become even more relevant and potentially even more valuable to the world is in front of us, is imminent, is, in my opinion, the next month or so, right? Maybe we don't have time for the winter meeting to have something actionable. Maybe we need to change, for example, the projects we are working on. Maybe we need to take SOGI and split it into and multiply it, right? Have more people refocus, but that's really my top of mind. And I'm taking a break to hear if anybody has any thoughts, either in person or online?
Charles got a question, so please go ahead.
Not a question, more a comment. I mean, I think that from the work of WeQuake, even before up to now, has been to also to very much look at what has been done and see how, I mean, evaluate performances and also lay out ways to look at this in a good way. And I think that role could even be stronger with the development of AI to really work on the strength of what WeQuake are with the knowledge that we have, but also evaluate and also judge whether things are really coming out in a good way. I mean, the paper Margaret wrote a couple of years ago about the performance of no reference metric was now that was Margaret's contribution, but that was very much in the spirit of WeQuake and all the evaluating projects that has been done. And maybe we should have be stronger on that part, how to also lay out the ground rules for what is a good metric and how should we do it. I mean, also a subjective campaign for evaluating various AI generated objective metrics could be a very valuable results coming from WeQuake. And we since it's a mixed community, we also have we could have the independence of looking at from the third point of view.
Thank you, Shell. I saw a couple of hands. Please keep me honest. I think Mikolai first, maybe Alex next. Anybody else? And Lucian?
I will use the opportunity. I've got mic.
You hold the microphone, so I cannot.
Exactly.
Okay, go ahead. Let's try to keep it. Again, I don't expect this to finish. It's a controversial but very important topic to me. So let's try to keep it short for now.
Okay, fully agree with Shell, with especially AI, that independent testing will be very, very important, or is very important. And the second thing is that, in my opinion, we should go more into the quality related to AI systems, both video and like how it's created and how it's interacting with people. We still have expertise there, so this would be interesting, in my opinion.
So thank you. So first of all, I would say that I think people right now are divided into those who are still trying to keep their eyes shut on the AI, and the other ones who already try to jump into this train. I think we should probably jump into this train because we cannot neglect AI anymore. This is one thing, and the second thing, because I want to keep it very short, that I've just finished my slides for the SOGAI this afternoon, when I proposed some extension, and I believe perhaps SOGAI should be really like a driving, or one of the driving projects in this group. Now it was still quite limited, but I think in the future it will grow. Okay, that's everything, and we can continue during the SOGAI session.
Thank you. Let's give it down. Alex.
Yeah, I think this very good points, and I really completely appreciate your opinion. So I think we can really narrow it down to, I think databases is really something we can definitely contribute. Good databases, right, which we consider to be valid and could be used for model development, for example, right? Also for benchmarking. I think we also did that in the past, right? So the WeQuake database are currently used. I mean, WeQuake related databases. The other one is the independent testing and good practice for evaluating, and that is something maybe where we could even, not sure there's really a sufficient standardization around this also, right? I mean, how do you say that your model is good, right? I mean, there are so many papers out there, and of course, what we did in the past in ITU is that we had dedicated modeling projects, right, where specific, like J.Nora, for example, where specific models were then submitted and then evaluated and so on. But there are many activities outside there, and there has been in ITU also these kind of framework standards where it was more a standard describing how, for a given data set, a certain model would be evaluated, right? And in this kind of context, and then you have the outside of VQuack and ITU kind of models being developed, which are like VMAF. I mean, it's just everyone uses VMAF now. I mean, it's basically the ITU models are relatively useless or little used, let's say, right? And I really think it would be nice if we had a good take on and also good documentation. How can we at least have some guidelines of what a good model is, right? So, and then the third one, I think, third contribution would really be this video databases, right? So this whole video processing chain topic, I think, is a key that VQuack can deal with. Thank you.
Yeah. So, Camille.
Yeah, I have next comments. I'm not sure if you like to answer
Just a quick here. In my opinion, we are sitting really central to a whole lot of developments. It's like we are a kitchen and have all the ingredients here, right? We have data sets. We have methodologies, subjective, objective. We have cumulative centuries of experience on practicing the field of video quality. We just need to put everything together into a solid framework that somebody who is external can directly, let me say, jump in and say, hey, I'm not going to reinvent any wheel. I can see how the implementer's guide to video quality can come in and help. How exactly you run SSIM, because I've seen 20 different implementations, right? We have the databases. We have the work that Jack Hybrid about how we model individual contributors, right? It becomes even more relevant now. We have SOGAI. So we have a ton of material. But in my opinion, it takes two things. A vision, where we say, yeah, strategically we need to invest in that direction, whatever it means for each individual, right? If you're in academia, try to have your students work on this. If you're in industry, try to fund in whatever way you can that direction, vision, and you need to have the volunteers who will drive it in more concrete ways. So that's what I want to hopefully by the end of this meeting, walk away with.
So can I? So from perspective of formerly PhD student, I was starting to know the topic, and the two things I was missing, especially in ITU documents, is solid theoretical background for those. So I think we have like perfect combination of ingredients to actually make good theoretical background for the domain. And from my perspective, ITU is right now struggling with that. So you have different definitions for everything. So 5G KPI white paper, for example, actually fit this role. But also second thing is what you mentioned is like clear description how to get things done. So the only article I could find, for example, explaining one by one how to conduct a subjective experiment is one from Lucian and Margaret from like 10 years ago, yeah? And maybe typical venues are not placed to publish such papers, but I think it is our role to share it and to go to more in direction of comparable studies through explaining it how to get things done, to have more comparable studies.
Thank you. All right, we have, 2-3 minutes now? Pablo?
Two very short questions. So no answers, but question number one is, I'm just looking at the joint reports that we have from the last 25 years, and basically VQuack has been underlying driven by first television and then streaming, right? So are we sticking to those services, or which is the next, end user service which is going to drive us for the future? I think this is the main question underlying what Yanni was saying, and because it will really shape what we want to do in the future if we want to address new use cases which are not those two. That's the first one. And the second one is we have a slot for this on Friday that we might want to recall. I mean, we have already decided that Friday was going to be free, but the feature of VQuack was originally planned for Friday, and maybe we should make use of this slot.
Yeah, I think we moved part of it here, and the idea is to put it in Thursday and follow up there, maybe with the liaison statements. But again, if the group feels we need Friday, speak now.
We still have a lot of time for
Wednesday, yeah. Okay, with that, I think we are.
Just
Anybody online?
just a short comment is there is for example in JPEG we are JPEG AIC and JPEG AI also they're working in evaluation, for example, of the image compression codec, AI based image compression codec, or in MPEG there is also such activities. And also there is a standard that JPEG AIC just published this year on subject evaluation of compressed image. Also in my presentation, we are creating data set that include this AI-based compression and so on. This is very relevant activity to us. So maybe we can make it also official collaboration between VECOEC and JPEG, for example, and MPEG and so on.
Thank you, Moxen. So again, AI is overused, right? I want us to become at least more specific. So to me, there are three, I call them verticals, right? The first one I see, and because I see it a lot lately, is can a machine perform subjective evaluation instead of a human? It doesn't matter what's the content. The content could be generated by a machine, could be a camera, could be a combination, could be a mix of images and video and audio. But the fundamental question is, do you need a human behind the screen to give you an opinion? It's question number one. And that touches upon directly to all the subjective work we're doing. Second topic is, can content that's generated by a machine be evaluated in a better way, either by humans or again by a machine? The third topic is, can a system that processes a signal, enhancement, compression, streaming, can it be driven by a machine that does intelligent decisions? Again, the content could be generated by a machine, could be by camera, could be consumed by a machine or by a human eye. But the man in the middle, can it be not a man or a woman? Can it be it? Can it be? So I say there is, I don't think we should be addressing everything related to AI and video and audio and images, right? We should keep our expertise in what I think is the core DNA. The subjective evaluation of signals, multimedia signals, in particular images and video, right? And the creative process of it, the generation of such signals by a machine, because inherently there is a concept of quality. But again, lots of topic for discussion over the next 3.5 days. We are adjourned for the lunch break, and we return on, what time? 1 hour from now?
At 2, we should.
2, wow. We have a long 1 hour and 45-minute break. So enjoy the break for those remote, and we reconvene at 2 local time, or whatever time it is on your. Thank you.
And we'll lock this door. Yes,
with a physical key or an AI key? A smart key.
But it's smart enough to lock it. It's, also to unlock it. Organically split into
is the ETG, or at least one of the two ETG papers. Let me stand. Am I covered by the camera here or not? I'm okay? Yeah. So again, welcome back. I hope everybody had a good lunch or dinner or wherever you are, a break. According to the schedule, we have paper number 117, which, if I remember correctly, is Frosso, right? Frosini. Yeah. So before we get started, this let me ask if either Nabajit or no, I know Frosso is online, but I want to see if the chairs are online. Otherwise, I will be chairing. Okay, I don't see either Nabajit or Saman, who are the two co-chairs of ETG. Just a quick refresher. ETG is the new projects, I like to call it, right, or frontiers of in video quality group. It's an exploration group that brings new perspective that don't normally fit into the existing activities. And as such, we welcome Frosso. I believe Frosso's.
I'm here. Hello. Can you hear me?
He will be presenting to us her work. Frosso, can you do a quick mic check if we can hear you?
Yeah, can you hear me?
Yes, we can
does
hear
it
you
work?
loud and clear. Yeah, we can hear you loud and clear.
Okay.
I see Cell raising his hand, although. Cell?
Yeah, I just want to maybe should the recording be on or not in this
I see the
presentation?
recording on. I see at least a red button on the top left with 1
Oh, yeah,
hour
it is.
44
Okay, sorry.
minutes. So
Yeah, okay.
we have the recording going on?
Yes, it
And
looks like that.
Frosso, you are okay to be recorded?
Yes, of course.
Very good. So again, floor is yours, so feel free to share your screen and take us through the content.
Okay. So can you see the full screen of my presentation?
Yes.
We do here on the big room, and I hope the remote participants can do as well. Please continue.
Okay. So hello everyone, once again. I'm Frosini Duzzi, an associate researcher at FORTH, the Foundation for Research and Technology, LS, and I'm going to present to you a metric that we've studied the last months, and this is called the spike-based perceptual visual quality assessment metric. I'm working on image processing and assessment lately, and so this is the first approximation to try to involve some neuroscience models into the quality assessment. To have a short introduction, we're all aware that perceptual visual quality assessment is really challenging because we really try to do the best alignment with the human vision perception. But there are some artifacts or pixel misalignments, and most of the times the performance of the existing algorithms is not the expected one. So for full reference, no reference as well, the AI-based algorithms, there are some pros and cons. So for example, for the full reference, we need the original signal. This is not always the case. For the no reference, sometimes depending on the domain variability, we might see the performance of the algorithm changing. And for the AI-based algorithms, although the performance is really nice, we somehow need to interpret what the algorithm has learned. The robustness of the system also is really important. So we were thinking, why don't we try to propose to define an algorithm that is more biplausible, and so tries to involves into the learning process the biological visual encoding. So what happens in biology, in neuroscience, is the following. We have the neurons that encode the visual information into a sequence of spatiotemporal events. This is called spike train. And these are discrete events that are generated at discrete time instances. So the motivation behind this work is to adopt these neuroscience models that transform images into this code of spikes, and then try to measure the distance of these spike trains by using different approaches. I'm going to introduce them in the next slide, and see if this is closer to the subjective tests and the scores that like MOS, for example, or DMOS. So this is a proposed methodology. This is a full reference, first of all, full reference image quality assessment. So we use data sets where we have original and distorted images. And so both images, each pair is transformed into a sequence of spikes. We've used two different mechanisms to do so. The first one is the Poisson encoder, and the second one is the leaky integrate and fire model. So this is the output of this transformation, a sequence of discrete events. So the events are exactly the same. The only information they carry is the time its spike is generated. And so once the original and the distorted images are transformed, we've measured the distance between the spike trains using temporal and population approaches. And actually, we combined the two of them, we did the summation, and then the goal was to see the performance of the algorithm versus the mean opinion score and the DMOS. Let me begin with the spike generation mechanism. So each image is encoded into these spike trains. So having a time window, we had to generate the spikes and then discretize this time window into n bins, and then see what's the probability its generated spikes to belong at its different bin. So finally, its pixel intensity is now represented by a function S, where X and Y denote the location, and K, the time its spike is generated. And so we could have either a spike or not. So that could be a 0 or 1. So for the encoding models, we use the Poisson approach and the leaky integrate and fire. For the Poisson encoder, its pixel intensity controls the firing rate. So we have a very high intensity. It means that the firing rate would be denser. Otherwise, we won't have a lot of spikes. And so this is the way this pixel intensity is controls actually the firing rate, and that could be generated with two different modes. The first one is a stochastic one, where the outcome, so the spike train, could vary if we repeat the same experiment again. But since we wouldn't be able to interpret and reproduce exactly the same results, we preferred to we prefer the second mode, the deterministic one, where for each pair of images, the expected spike train output would be exactly the same. So now the spike train is related to the probability its generated spike belongs to a given bin, as provided by this formula. So this is the first model, and the second model is a well-known model from the neuroscience point of view. It's the LEAF model, the leaky integrate and fire. that approximates the way a biological neuron is activated. So this is the biological neuron, this is the sum of the neuron, and this neuron is activated when the environment transfers some important information that has to be captured and encoded. So that has been approximated by an electrical circuit with a resistance and a capacitor. And each time the voltage here the circuit reaches an upper threshold theta. So each time the voltage is higher or equal a threshold, a spike is emitted, and then we reset the circuit and we start the whole process all over again. So the metric we propose, once we have generated with these two approaches the spike trains, is to measure the temporal distance between the spike trains. This is the temporal differences computed by the Varosum distance. This is a well-known approach, especially for this domain. And the second one was the population level spectral difference when we integrate when we integrate the activation mechanism, the activation of a population of neurons. So we see the global view of a population of neurons. And so the proposed quality metric Q, the spike PVQA, actually is a summation of the Van Rossum distance and the Sikon-Wasserstein distance. That was used, the Sikon-Wasserstein, for the population level difference. And the full formula also includes two weights. If we need to pay more attention to the temporal distance or the population one. And so then we need to evaluate the performance of the proposed metric versus the subjective test. So Q is the proposed metric, me is a subjective score, either MOS or DMOS. And so for each pair of images, we compute Q, we have M, and so we use the Pearson and the Spearman correlation to evaluate the performance and the closeness of the two. So these are some results. We used a different data set, the SID22 data set that basically consists of pair of images that are related to compression artifacts. So for its different compression algorithm, we have a pair of images, and then we see here the Varosum and the Sikon-Wasserstein, so the temporal and the population distances, and the combination of the two. And we can see that the performance of the algorithm, is better for the Spearman correlation than the Pearson, as a first comment. And then we evaluated this performance to the MOS that is provided for the SID22 dataset. And for the Poisson, the first encoder, and the Leaf, the second method, we can see that the correlation is really high for most of the algorithms, and the best performance is given for the JPEG algorithm. It is approximately 392 for the Poisson process and 91 for the Leaf. Then we tested another data set. This is the CADID 10K. Here are the best distortion cases, well, the distortion cases where the algorithm had the best performance. So again, we have the Varosum, the Sikon-Wasserstein, and the combination of the two. So the proposed algorithm here. We see that actually the ones that are listed here are distortions that are related to compression artifacts. I'm sorry. I have some notes. of the different distortions. Okay, it's blurs, noise, compression artifacts, brightness, and contrast changes. So these distortions that are listed over here. Yes.
You're now on the presenter mode where we barely see your slides.
Okay. I just wanted to
read your notes. I
my
understand.
note. Okay.
Please go back to full screen.
Okay. Yeah, sure. So these are related to this kind of distortions, and here we have the full dataset with all the different kind of distortions. We know that for some kind of distortions that, for example, are related to color or Can you hear me?
Yes, we can hear you.
Okay,
I guess there was perhaps some small drop, but now you're okay. Please continue.
Okay. There are some distortions related to color or changes sorry, I need to see my note again because there are too many and oh yeah. Okay, for spatial distortions, yes, it's spatial distortions. So that the algorithm doesn't really perform really well, but for compression artifacts and contrast sensitivity, we see that the algorithm does really well compared to the DEMOS test. And so here we compare to the state of the art. All the state of the art for reference metrics have been tested on these two data sets. And here we see, according to the literature, the performance of the salt and the proposed algorithm for poison and the leaf approach. And we see, for example, for the CADIC, data set, the performance is close to VMAF. And for the SID data set, we approximate the DSSIM that gives the best Spearman correlation for the SID. And it's like really close to the best performance. Just to sum up, here we propose an ANOVA by plausible full reference image quality assessment that uses neuroscience models in order to transform images into spike trains and then compare for each pair these spike trains and by computing the temporal and the population distances. And then we'll compare to some subjective opinion scores that are provided with the data sets. And we see that the performance of the algorithm is it's really close to the state of the art. I would like to leave some notes here that I mentioned that, for example, for CADIC, there are some distortions that the algorithm doesn't really work very well. And we could interpret this as the fact that the models that we use from neuroscience are basically detecting contrast changes. So probably to extend or improve the performance, we need to adapt or consider some algorithms that, for example, describe how color is perceived and etc. So this is all for now. thank you for listening, and please, I will be happy to have a discussion on that.
All right, thank you. Thank you, Froso. I'm opening the floor for questions. I see Alex. Maybe you can use the other microphone, or I'll pass. Yeah. Thank you.
I need to find the group. Sorry. Oh my God, that's a disaster. Sorry.
Can you see us?
Yes. Just give me a minute.
You may want to stop sharing your screen.
Yes, this is what I'm trying to do. It's here, over here. Nice.
Okay.
Yes, please.
Thank you.
Yeah, thank you very much. I find this very interesting. Can you maybe, project a little bit into the future? What do you think? What kind of information may be best captured with this approach, right? If you compare it with what VMAF does, for example, or some other of the metrics that you have included, right? So if you consider it in some kind of information representation sense, right? So what do you think is going to be captured? This is not a provocative question, in the contrary, right? It's really just a question. So what's your assumption? What could be better captured beyond, of course, being a bit more representative of how nature does it? So why could nature do it better, and what can we learn from it in this representation? That's my question.
Yes, thank you. So as I mentioned at the end of my presentation, for example, at the moment, we are currently using models that capture contrast because we had the experience, we used it for compression, for compressing visual information. So we were more familiar, but I think that the main benefit is that the more we understand the mechanisms of the system and the more we are able to describe them mathematically, we can build up existing models and make them more efficient. So instead of now only considering the contrast as this metric does, we might be able maybe to capture some color changes, some semantic changes, something that really captures the attention. So I think that we can extend even this approach and maybe improve the models according to this direction. For me, this is also very new. It's the first time that I try to approximate this kind of algorithms that does the assessment. I mean, so I need to explore.
So let me continue a little bit. This is Yanni again. So I think a couple of comments here. The spike train, is it a fair statement that it depends only on the pixel luminance of the specific pixel, right?
Mm-hmm.
So I think
Yes,
that one important element that could be added is, we know that there is inhibition that happens from neighboring pixels, right? So when you talk about contrast sensitivity function, you're not talking about how much contrast one pixel, but how the neighborhood, for example, contrast affects what you see on the current pixel. So one, I can say, question or proposal from me is to explore better models that really express the trains hopefully closer to, as you said, the way the human eye sees. That's one point. The second question I have is, can you elaborate a little bit? And I think I also gave you privately in a preview I saw, okay, there is this transformation phase, which seems to be lightweight in terms of complexity, right? To take the pixel,
yes,
make it into a spectrum is light. How about the other distances involved? How complex are they in their evaluation compared to, say, the complexity of VMAF? How fast does this run right now?
Well, the approach, it is fast. I mean, for the, well, fast, it depends on computer and many different stuff, but I mean, there's no mechanism that really demands a lot of time and has a computational effort. But I'm not ready to answer this question yet. And I agree with your comments, and thank you that for the moment, for example, for leaf, we do not even consider there is a refractory period, for example, for a neuron to reset the voltage of the membrane, and then after this period that is inactivated somehow, it starts the processing and receiving some more inputs again. So we do not even consider this parameter with this model. So by considering, for example, the inhibition, maybe we can see an improvement at the population distance, because the population distance, to be honest, doesn't contribute that strong to the final score. It's more the temporal distance, and this is normal because time is what matters in this kind of approaches. But thank you very much for your comments.
No. Thank you. Anybody else comment or question for Froso? Yeah, Dietmar next to me would like to ask.
Yes, thank you very much for this presentation. I'm not familiar with the spike trains. I think I've seen a presentation of yours last year on it already, but I don't know the details here. Now, could you please maybe share some more details, like what are the parameters of the model, and then how did you choose these parameters? Did you use some training data set, so in order to optimize the parameter settings? That's my one question. And the other one is, you combined two methods. You had a table and you said this is method 1 and this is method 2, and your proposal was the combination of both. Now, when I looked at the table, the correlation for the second methods were near 0. And so you combined one method that was effective and one that was ineffective, and then the combined version was even less effective than the first one, which was effective. So I don't understand why you chose this combination. Wouldn't it have been better just to use the first one?
You're right. There is just a slight improvement when we combine the two. So we've done an extended study of how to tune actually these two weights of the two different distances. And well, of course, according to this study that I didn't present here, the outcome was that the first one is the most important, so we should pay more attention to the first one. But we, at the end of the day, since there was even a very small improvement, we wanted to keep, in neuroscience, most of the times we pay attention on both time and the population, because they are both really important. So this is why we use the two weights, and then if we improve the model, we can continue tuning the weights and find the best parameters. So for the parameters of the models, for example, the leaf model has a lot of parameters, and we've done agreed search to find the best performance of the final outcome. Well, it's the problem is that there is no protocol, if I can use this word, to say that when you are in a space and you have an image, you can transform this information with this given way into spikes. So there are many different ways. As well, there are many different ways to interpret the spikes. So we need to study, compare, and then decide what's the best solution. So I'm not sure if I have answered your questions in this way.
Dietmar, are you covered?
I think you said that, okay, you experimented with it and you looked at the results and then you chose the parameters based on your impression, but you didn't use a data set and an algorithm to optimize the parameters like simulated annealing or something, or like you didn't use part of the carded data set to train your method to perform well. Not yet, but
no,
that
we
could be done
haven't
later,
done
yeah.
this
Yeah,
yet.
yeah.
Yes, for sure. Thank you.
Thank you. Anybody else? Well, I see none there for first, so thank you very much.
Thank you.
Now we are ready to move on. Let me see do you have the list handy? Okay, we have Sogai, and again, I'm not sure if Lucas or Abhijay or Jenjong are available. If not, I will be sharing again. Okay, let me check if the presenters are ready. So the first presentation is for...
He was here.
Okay. So I will let then Patrick introduce himself.
Hello, everyone. I'm Patrick Pajerski. I'm a third-year ICT student of AGH University in Krakow, and with my friends Szymon Manijak and Szymon Leśniak, and help of PhDs Jarosław Bułat, Lucian Janowski, and David Juszka, we made a study on human ability to detect realistic AI videos. We wanted to check what is the accuracy of human detection between the realistic AI videos and realistic videos. So first of all, we will speak about methodology and data set. So our study depends on generative models, state-of-art models, for small ones, locals like WAN 2.2 and Hunyuan videos, which we are using on ComfyUI. And then at the very end of our experiment, we had opportunity to use some cloud large online models like Kling, Minmax Helio, Solar, Cadence, and VO2. And then this is a workflow of local small model. As you can see, there are some parts. There is the part where are you loading the preset of the model. Here you have some values about the generated video, like the size of the video and length. Very important part, the prompt part. As you can see, there are green box and red box. In the green box, you are pasting the actual prompt, what the video was meant to be, and negative prompt is what we don't want in this video. And then you have some two samplers. There are some values and I'm sorry, I'm stressing. Okay, and there is the output. This is one of our first prompt example. We were generating the videos for a month and a half, so the prompts at the end were very big. And this is our process of dataset preparation. So we, in the 1.5 month, generated over 500 raw videos, a mix of local and cloud-based models. Then we selected by ourselves 13 most realistic AI videos, and then we took from internet some 13 other real videos. At the very end, we add one obvious AI videos as this validation video. And to make the experiment good and prepared, we standardize every sequences to have the same frame per second and size. So this is how our platform look like. This is the introduction. So a quick instruction how our scale works, 1 to 5. So 1 was obviously AI, and 5 was the real video. Some important rules like each video will be shown once. You cannot pause or rewind the video. And the very interesting thing was that we give a participant opportunity to rate the video at any time. So he could see the video and after even 1 second rate the video. And this is the view how the rating was. So this is our video and buttons to make their requests. So another important thing, participant profile. So the test was completely voluntary. Target grabbed only students of AGH University of Krakow. We shared the link across across the campus of AGH, so we can tell the estimated age range was between 19 and 23 years old, and final sample was 112.74. This is because some of them didn't finish the fall assessment. And after validating responses, we got 101 responses. And the important part, data cleansing and validation. So there was 2 criteria how we taking the responses. The first was a full survey competition. So for valid response, we had to take only the people who completed the whole experiment. And the second one, as I said, we had this control sample, very obvious, and we took only the people who guessed 1 or 2 on this sample. Why 2? Because some of them don't want to guess 1. And I want to share global results with you, or accuracy metric. So we measure accuracy of our samples by this yes, this formula. Sorry. Maybe it looks really hard, but it's really simple. For real video, we took the ratings of 1 and 2, and 3, 4, and 5 were not take part in. And for the AI videos, we took only the 4 and 5 as 1 and rest of as 0. Okay, let's go. So this is the accuracy box plot. As we can see, the overall accuracy was 62.7%. For AI video was slightly lower, 56.7%. And for real video, the accuracy was 68.7%. This is the slide. The plot is really big. For each sequence, you can see a lot of values of plots, and each sequence has its own first frame and accuracy. Then we took some objective metrics to check if we can tell in some objective ways that why the accuracy was that. So first we checked accuracy versus the screen size of a participant. So there were the dots are users' pixel squared values, and we fitted overall accuracy line trained. As you can see, the minimum value is around here, 0.58% accuracy. I'm considering that these people should be outlier. There only one people with 4K display, and there are some lower displays like mobile phones, because our validating platform was hosted on web. So there were some mobile phones and personal computers, and in this point there were 0.59 accuracy. So as you can see, they are slightly improved in screen size from 59% accuracy to 65% accuracy at full screen. So there is another plot of accuracy of brightness, and as you can see, it is hard to tell something from this plot because there is no correlation between accuracy and brightness. And the interesting thing is that the AI-generated video have brightness in around 60 and 100 mean brightness. Okay, another plot. So this is the spatial and temporal information against our accuracy. And for real videos, there was also no correlation. But if we check correlation in AI videos, as the spatial information is increasing, so the video have more details, the accuracy was also increasing. And on the x-axis, if the video had more motion, so temporal information, the accuracy also slightly increased. So, and there are our correlation values. This was calculated with Pearson correlation. And last but not least, we took some detailed case studies. So our test had some interesting distribution, like this one for this video. So this is the bimodal distribution, as you can see. So basically, there were two groups of people. The one who thinks the video is AI, so 1 and 2. A small amount of people they didn't know, and a lot of people who thinks the video was real. So another one. This is the AI video with lowest accuracy. As you can see, there is a thermometer with changing temperature. It is hard to tell that this is AI, basically because the video was generated from a picture and is static. So this is how it looks like. And at the end we had one video. This is a real video, and it has nearly uniform rating distribution. So you can tell the people were guessing by taking a dice and throwing, basically. And this is the end of my presentation. So conclusion of my presentation is that the generative models are getting better by the time. The accuracy of detecting real videos are around 63%. And there are no objective metrics that can somehow tell what makes that the accuracy is about 63%. And I'm really thankful for your time, and this is the end.
Thank you for your presentation. I had a question. You used different models.
Yes.
Did you find that some models perform better than others?
Yes, of course. Like the local models, we have used the 1.2.2 and Hunyuan video. The 1.2 give us around, I have 50 good samples overall. But the Hunyuan video we tested make overall, I think 100 samples, and only one sample was good. So there are a lot of differences between models. From if you look at the online models, the models were meant to generate something else, like Halio. I will go back to the slide with Min-Max Halio is great at generating movement videos like dancing or something else. Kling was overall the best from online models. If you look at the VO2, it was not good. Just not good, and there was watermark in the bottom right, so we didn't use any of the model samples. And I think Sora and Sidens was not good either for this study.
Thank you.
Thank you. It's really good work. So congrats. I have a question about scale. Why you use this particular scale with the percent? Or did you have any thoughts about scale, or it was? Oh yeah.
You mean this one? Yes.
Yes.
So at the beginning we have just numbers 1, 2, 3, 4, 5. And we were talking a lot about this guy with Lucian, and Lucian proposed us to just make it in percent. So maybe it is easier to tell what do you need to do on this scale.
Yeah, I thought so. Solution, why the scale?
It was just consulting before running the test. There was not too much time to really analyze it. But the reason was simple. Yeah, the question was, is it real or not? So the scale looks reasonable, but it's not like coming from literature or something like that. For me, what is the most interesting? Can you come back to the slide with all the distributions? is that because in my opinion, when we speak about the quality for AI, we can think about this test as very, we generate a lot of videos and already pick up the ones that are very good, that are very realistic. So in theory, here should be, like almost everything should be rated as real video. Still it's not, so yet we are not there, or people are better and better in detecting AI video. Because in my opinion, the quality for AI video will be very strongly related to ability of saying that it is AI video. Like I was in a museum here in Krakow, there is a new museum with Van Gogh, and there are some images that were changed to be movie, like moving old images. And then you kind of know that this is AI simply because they couldn't make a movie back then. So it's you look at it already with some kind of suspicion, and you're looking for errors and stuff like that. So this is not the same. But here people didn't know. And so what is for me interesting from some point of view is that those distributions are different than we see in typical quality evaluation. So for that kind of evaluations, okay, yeah, thank you. So for that we will need probably some slightly different models to understand that the test went correct and that people understood everything, etc. Yeah, like for example, we definitely don't expect to have a high correlation between testers, like very high correlation, simply because we see that they are very different in opinions, and this is like a natural part of the story.
Someone else?
Yeah, I want to follow up. Yeah, because to some extent you have two questions there, like, is it AI or not, and how sure you are, yeah? And with this scale you have, I think, two different things collapsed into one, yeah? And that might be generating some problems.
You think so? Why? If you ask only how sure you are this is AI or not, then this will be exactly that.
Okay, so maybe I didn't understand the scale after all.
I want to add another dimension to the discussion, because up to now we have been discussing about the, let me say, the pixel quality of the image. But if you ask a person in the normal society about what he or she thinks about the quality of an AI image, is the closeness to the question or to the prompt that the person prepared. And that's another dimension that should be taken into account, because it could be that the image quality is excellent, but it is not what I aim when I make a prompt. No, I just say that it's a different dimension that shouldn't be dropped.
Yeah, I think most people, thank you for the presentation, by the way. Good job. I think we are used to judge quality based on what we like to say, fidelity of some kind of mental reference you have, right? So when I show you a picture and you say, again, in NoRef 1 to 5, somehow has this model that, okay, a 5 looks like this, right? A 1 looks like this. In this case, it is definitely a different question you're asking, right? We're not asking whether that's a beautiful dog or a, or a plausible. We're just saying, do you believe a human created this or a machine created this, right? Now, at some point, in my opinion, we need to be able to find either multidimensional questionnaires or transform the questions. Because I believe when it comes to, let's say, use the word now, authenticity of a content, if you want to use one term to describe what you're trying to do, I do not believe that humans will be used because of the large number of created content, right? So even if you devise a good methodology and you find some meaningful results, the question whether something is authentic or not, in the long run, is going to be answered programmatically or systematically by some mechanism that we can cover in a different topic. For me, it's more important to find a way to go beyond who created it and resurface the question, is this good artificial content or bad artificial content? So to bring back the 1 to 5, let's say ACR question, accepting the fact that this is artificial content. So I would like to see personally, without asking the person to evaluate, is it good, is it machine or human, we have the classic ACR scale and then infer by splitting and say here, the 13 that I know were AI generated received, say, an average mean opinion score of 3.2, and the ones created by cameras were 3.5. Because that's how we should be tracking, in my opinion, how good the machine is getting into producing good content. Because to answer the question, is it or is it not, is not a very relevant question, in my opinion. But I'll leave it. I think I see Moxen raising his hand.
Hi, thank you for the presentation. I'm following in your comment. So it's also probably depends what you ask the subject about the video, right? Or the image. If it is, let's say, AI generated image, it depends what you are evaluating, what you mean with the quality of AI generated image, right?
Again, fundamentally, I think we should, at some point, now we're at the point where we want to understand, is it not or is it or isn't it generated? But I think very soon we're going to go past that question. It's going to become not an issue.
True. I mean, right? Assume we know that they are, which one is AI generated, which one is human generated, which one is natural image. But for example, in existing data set, we have a screen content image as well, right? It will be the same as you evaluate a screen content image or something like that, which is not natural image, but some other thing. So it will be evaluated that way. But I mean, depend also what you're asking the subject for that with the quality, right?
Yeah. But Moxen, my point is that what exactly are we asking today when we show traditional video, right? On a scale of 1 to 5, 1 being bad and 5 being excellent, how do you rate this video, right? I think that same question can be asked for Gen AI content, silently accepting that if at some point you see that the Gen AI content is rated higher than cameras, that may be the tipping point, or we may already be there, right? Rather than trying to understand how many people can understand if it comes from a machine or not, I think we should be looking into what's the perceived quality of that content.
Yeah, but the quality is different than how it's realistic it is, or how will it look like natural thing. For example, when you evaluate in screen content, you might get the highest quality, but does not mean that this content is better than camera content, right?
Again, that's, I think, a philosophical, perhaps, debate. We can take it offline. But how are we doing in terms of time? So I know we should move forward. Okay. So, Moxen, we can take it offline. But thank you again. So what's the next presentation? Ah. Is it Pablo? Pablo, you may need to take this battery is running low, but give it a try. Oh, there is a mic there.
Okay, so good. This is well, no, okay, we are back. So it's me again. This is a small thinking exercise, mostly done with the help of Marta and Kamil as well, which is mostly about our jobs, right? So. Which is the role of QA research in the LLM era? So it's a bit of maybe what Yanni was mentioned this morning. So some perspective on that. Which somehow is about when I try to explain my research to my colleagues in my company. For instance, we should have somehow ask ourselves if we are kind of working for the right customers, for the right use case, or if we are kind of getting outdated, and whether what we have learned so far can be used for the next services, right? So the question could be, can we measure the quality of experience of ChatGPT? I mean, why are we measuring the quality of experience of YouTube, let's say, anymore? We should be measuring the quality of experience of ChatGPT. Just should be kind of the thinking of, okay, where the world is going to. So does it make sense? What does it mean? So let's try to simplify the problem, because I think that one of the problems that we have when we're trying to addressing the new type of content is that the scope is too broad, maybe. So let's try to find something kind of that we can attack. Right? So let's start by defining the goal, and the goal is QoE, right? And we will use the definition of user-reported QoE from the last white paper, because it shapes a bit the purpose of the research, right? So this is the quantification of the impact of a system on the user delight or annoyance, measured through self-report or behavioral psychological studies. This impact can be caused by the application, network, or hardware, and is moderated by the usage context. So somehow what we need to understand is if there's some relation between the resources that we spend doing creating some content or distributing some content and the quality that we get from it. This is what we have been using for streaming in the last, or television in the last 20 years, right? So this is why we need BMAF, or this is why we need all the subjective studies to understand how much bits do we need for our pixels and all that, right? So can we do a similar exercise in this LLM thing? So the first, again, is try to simplify the scope. So which is the core, in the generative world and in these days, let's say the services based on LLMs are very complex. So let's try to restrict the study or the design to the quality of the model, right? So let's fix that the system that we're measuring, so our independent variable, the system that we want to test, is the model, and everything around the model, which is a lot. So all the tooling, all the application itself will be just the context where we're measuring, right? So let's try to restrict our question to, okay, can we give a QoE value to the GPT 5.5 model, or compared to GPT 5.3, right? That would be a valid approach. And of course, this might be not only for LLMs, that could be other kind of generative model. I think that the way of thinking, or how we address or structure the problem is what we think might be useful for discussion. Okay. So what we did is, let's compare it to what we are doing for video, and let's check for similarities and differences. So we have on the left this path dependency model that actually Lucian brought here a few meetings ago, I think. And then you were the first one presenting it actually in the beginning, and then Camille developed it and published it in Comex a couple of years ago as well. So this is on the left. This is more or less a useful simplification of what we typically do in our studies, right? So we have the content that creates some delight or annoyance in the user that will move to some behavior, and this delight or annoyance is moderated by the system, so our HRC, which will somehow cascade through a couple of layers, right? So what we can say the objective quality, and then we add the perception, and then we have like the subjective or perceived quality up to some point. So in the LLM world, we have something similar, right? We have a model, we add some tasks to the model, and we have some ways of measuring the quality, but there are some obvious differences. So I will go to the main ones. And so the first one is that, there's some analogous so there's some metrics for that, right? So there's some equivalent to the PSNR of the models, which are the benchmarks. So there are benchmarks out there that people throw to the models and somehow give a number of how good the model is doing some tasks, right? And there are also some metrics that are there's some methods. So there's an ITU methodology for chatbots, for instance, that can give you some ideas of the perceived quality as well. But both of them are multidimensional by definition, right? So you can average the benchmark, but by definition, these models are complex and they're typically address different tasks. So it creates a complexity which is different from what we have. I mean, we probably don't have a single MOS for all the use cases, even for a fixed model, right? It will depend a lot on the task. Second thing is that this task is not a content, it's typically an interaction. So even if we code the interaction for a benchmark, up to some points, it's expected to be interactive and iterative, right? So the typical usage of this is that you don't get the result from your first iteration. So the test method is more complex, it adds more variability. And the third one, and so it's not the most important for the application, but it's critical for the system part, is that the bottleneck is not communication anymore, it's computing, right? And this changes everything in the x-axis, right? So the resource that we are now competing for is not the bits, it's typically the energy. It's ultimately the energy, right? So can we get some grasps on this? So can we see if some of the tools that we have developed in the past for video still hold for that? So on the objective quality part, so let's start from the beginning. Let's start to see basically if we can find these rate distortion curves that we have in video in the LLM world. So we basically checked for benchmarks. So our independent variable is the system, and in this case we will restrict to the very basics. So picking different models and restricting computing in two ways, which is either different quantized versions of the same model, or adding computing time. Basically, you can tune the model to think for longer. That will probably get better results, but adding latency, which at the end of the day will be computing time and therefore energy. And the result will be the benchmark, and we will pick the LLM leaderboard. So one public benchmark that is out there in the available right now. And again, these benchmarks are multidimensional. So we will take for the graphics the average scores of 6 different benchmarks that are using six different tasks, right? And again, the numbers itself or the models themselves are not very important because they change daily. The meaningful part is that at least in the computing part, we see these trade-offs. So there's room for this cost, this array distortion curves that should be rethought for this world, right? So we see for a number of models. So the dots on the left are a few models, the scatter plot, the quality of the benchmark against the memory that they use. And then for a family of models, these are the curves on the right, which is depending on different quantification types. You see that if you give more memory, it increases the quality a bit. It depends a bit on the model. And something similar happens with the time. So of course, we don't have this very nice convex hull curves that we got with PSNR, but still we have some tendencies that we might want to characterize in the future, us or somebody else. But these trade-offs between quality and resources exist, right? Interestingly enough, in the existing benchmarks, there's not many people studying trade-offs between bits, like bit rate and quality, right? So there's not many use cases where you can find that adding more information to the system will improve the quality, which would be like the bit rate to quality things. And this is why we don't have graphs for that. And the other thing to think about is the subjective quality. So how can we model the quality provided by this new systems, right? So main message is that probably we can reuse the tools as we've been discussing today, but we will need to to fine-tune them. We need to find the right tools, and probably the most important thing is that it's more difficult to justify that we are going to have a single value to express the quality of one of these models. Right? Also, we are going to have higher degree of variability because of the difference of tasks and the difference of tooling and applications, right? So, of course, there's always a difference between the model and the application. It happens in video, right? So, you see the video, but you see the video in the context of whatever, TikTok or YouTube or whatever application, right? So it's not the video on its own, but probably in video, the quality of the content is a bit less tied to the application than what it is in the LLM world, where the tooling makes a lot of the value, right? So it's not only the model; it's how with same models you can get different results if you have the proper tools. So all this is going to create a lot of problems, let's say. But I think it's good to structure the problems and try to really kind of write these kind of diagrams, right? So figure out which our variables are, what are we measuring, and which tools can we bring from our past to the future, right? So this is a small summary of the conclusions. Again, it's just to think together about this, right? So what do you think about this, let's say? But more or less some research lines that we think are relevant for us as a community, right? So first of all, understanding the QoE dimensions, which will depend on the use case. And again, we probably need to streamline or to really determine which is the system that we are going to test. So probably determining the system under test is the first thing to really understand. Which are the benchmarks that are more relevant from the perspective of the people, right? I didn't mention it, but some of the benchmarks that are out there are actually rated by people, or are automatically rated by machines. So in none of them, there's a good understanding of the distribution of the scores of the users, something like that. So building the right benchmarks, especially the benchmarks we depend on people, is something that is also relevant for us, right? Of course, establishing the proper subjective protocols, understanding the structure of the statistics of what we measure, and also figuring out if our subject models apply to that or not, or how. And and the last one for the future of the 5G KPI team is which are the trade-offs now, right? So which are the new QoE to QoE or QoS to QoE relationships, which will mostly depend on computing, which changes everything from the system part significantly. So this is a really new thing. This is the first time that computing plays a major role in the communication part for online services, like forever. I mean, compared to, we've been from telephony, television, streaming. The bottleneck was always on the bandwidth, but now the bottleneck is on the computing part, which changes a lot of things from many perspectives. That's all. So thanks, and of course, open for questions and discussion. That was the purpose.
Okay. Any questions, comments for Pablo?
Thank you very much for very interesting topic. I like it very much. I'm wondering if still, even if we know it's multidimensional, then maybe the kind of market would like to still have just one value, yeah? So at the end, probably we have to cook it to some kind of, well, not necessarily we, but someone will cook it to a single value anyway. But I also wondering, do you know technically about the trade-off? Is it really like kind of possible or things like that? Because you are speaking about like using different models for different questions, yeah? But is it really feasible to do it? You know something about it?
So I think that, the models are developing so fast that now it's difficult to track this. So these things more or less address both of the questions, right? So, but again, this is from a benchmark with models which probably don't make sense today because it's from some months ago or whatever, right? So, on the one hand, you can take some benchmarks and do the mean, and okay, we have a number, so we have a quality number here. How meaningful it is, that's questionable. So, probably understanding how meaningful this number is part of the research, right? So,
what I mean is that if you decide that well, I get a good quality with VRAM, whatever, 10 to the power of 1, yeah, or 10 gigabytes. It's a reasonable question, but for some questions, it's like, well, I'm taking the analogy from video, yeah. If the video is more complex, I should put more bits on it, and then compress it differently than if it's like easy to compress. Do you think that this kind of optimization is even possible? So knowing the question, can I kind of fit it to a different systems or not really? We probably don't know, yeah.
I mean, I don't know. Not generally, but I guess that, I mean, this trade-off exists, right? So the time one, it's actually something that is integrated into the tools, right? You can tell. So you can tell your system. So take more time or less time to think about the problem, right? So this is something that's already embedded in the applications anyway, right? So somehow characterizing is kind of relevant. You can also select the model as well. So in a way, and it makes sense because the tokens are different on price, right? So actually, these things are kind of manually happening these days. If you have a limited budget of tokens to spend on your computing task, you need to decide if you go to the latest model or to the previous one, and if you make the model think more or less, right? So can we make it more systematic instead of guesswork? Probably when technology is more mature, it should happen. But the problem is there, and the solution is somehow manually is happening, right?
Camille?
So I will go back to the first part of the multidimensionality. We were writing and reading about multidimensionality of quality also for video, and it is approximated by one metric of your choice and ACR basically, yeah? So you can do that for the engineering part at least, yeah? So we can approximate with that. So I'm not sure about that part, if it's possible or not to collapse it to one metric or one scale. But for me, what is different is that you have this temporal aspect and you have interaction. So it is the question of whether you will be answering about the quality of one answer, or you will be judging whole model by whole set of interaction, yeah? So you fulfill full task and then you rate the model. So that part is different, and this temporality and this interaction, I think it is the part that makes it more probable to be multidimensional.
Firstly, maybe I missed something, but as I remember, you said that you are going only with ChatGPT, right? And no different models.
No. I mean, ChatGPT was an example, but we are actually testing different models. Well, we are not testing models at all. We are just, but I mean, the benchmark that we took is actually with a number of different models. Not even GPT is there. So this is Qwen, OPT, CodeGen, whatever. So this is totally generic. ChatGPT was just an example of a model, of an application, and GPT 5.x an example of a model. But the whole way of thinking is generic.
Okay. Then my question became the suggestion. For example, I'm working for underwater images, but some AI models are generating a different type of quality. For example, for underwater images, different AI is better, but for NASA, different generators are better. So data set classification here, I think important. Data, but what type of video? Some models are just testing frames. Some models are for blur. There can be some bias. So if there's if you add for next step maybe some classification and model bias, if you can measure the bias of models, it can be different type of work, and maybe you can increase the quality. Maybe just idea.
Yeah, thank you. So that's a nice thing, yeah, because I think that, let me reword it in a different way. So we know that the task is complex and the different models may be better or worse to different tasks. We kind of assume that it would imply that the benchmark could be multidimensional and the context is more important. But the bias thing is interesting, is that we might want to calibrate this difference in a quantitative way, so that we have we could have a mixture of qualities, right? So we have like a generic quality and then some kind of deviation depending on the application, which is a nice way of decomposing the problem in a way which is more tractable. So
yeah, actually, it is not the same work, but I read one research. A friend make a comparison for DALL-E and, for example, ChatGPT guess is it fake or not, or Gemini guess is it fake or not. There are different models. Stable diffusion, DALL-E. If I put DALL-E and after that if I say Gemini is worse than ChatGPT, so it is not a good work, I think. Or if I say stable diffusion is working for Gemini better, and I think it is not a good work. Need to check bias, and after that why we are having this type of because quality of experiment can give different result. If you adjust bias, maybe you can put some penalty, and after that it can be more realistic and more trustable result. Just advice.
Oh, great. Actually, thinking about that, so something that we complained, a problem that we have from the past when checking this typical benchmark of codecs is that you get, this codec gives a correlation of 0.99973 and the other one is 974, and then this is better than the other, right? So this is a typical thing in benchmarking, which we know that it doesn't make much sense if we don't take into account the variability of the user, something like that. So something that is also important here is that the model themselves are also stochastic. So we might be able to model the variability, the randomness of the model itself. That could also be an input to the modeling of the thing. So it's not only that the content might create some variability. It's not only that the users add some variability. It's that the models are stochastic by definition, right? So somehow the uncertainty of the task could be added, and the variability of, not considering the model as a fixed points, but somehow kind of distribution of the responses could account for modeling bias or things like that in the modeling themselves. So that's also a difference that is not captured here, but I think it's a nice idea.
Thank you.
Thank you.
Okay, Pablo, are you planning, and Kamil, are you planning to narrow this topic to the content, LLM-generated video content, or you are just widening the scope of this project? Because I was wondering if you are planning to follow this task here in VQuack, or just to develop the audience for this presentation and this idea.
I just wanted to bring the discussion here.
Okay.
My main concern right now is about the point number 3, right? So my main concern, my personal/professional concern is about what does it imply for the network resources, right?
Okay.
And in this case, starting from LLMs is a good starting point, because these are like the models which are by far consuming more resources in the network in general these days, right? But of course, we will have the same trade-offs for any other artificial intelligence models like image generation or whatever, or similar ones, because for all of them, computing is the main resource. So this is we will have like similar problems, and probably if you put another model there, like not an LLM but diffusion model for image generation, we have a similar architecture of the problem, right? So
we are not going to suggest as an activity for this this group.
Not now. I don't. I'm not. I mean, the idea is not mature enough, at least for me, to suggest any activity. But definitely open for discussion or ideas, or interested in joining into new things if they
wonderful
arrive.
topic. Thank you.
For me, the most interesting parts are first and second. But I think to have any reasonable resources spent on that, first we have to have some idea about the third one, yeah. Because then you have actually reason why you should work on first and second part. And I think it's first step forward, but we will see. For sure, I would love to work on that in the future, but we'll see.
Okay. I don't know if there's any other question. We have 4 minutes until the break.
Yes, that's like perfect timing. Eh? Any more questions for now? Remember, so guys returning after the coffee break? We are still to confirm at least 2 of the presenters, but we have one already. One, only one, okay. Very good. Any more questions for now? If not, thank you very much, Pablo. And we take a 3-minute earlier break to make up for the for the shorter break this morning, okay? So let's try to be back on the hour, eh?